JSONH, a story in mobile API optimization and how to get data stuff faster. Back in the day, when I could barely pronounce API, and for me, JavaScript was some esoteric magic that induced pain and wonder, mobile phones were unwieldy bricks of plastic and metal, with huge antennas which held a hefty charge of power. Along came WAP as the new kid on the block. I had to print out yet another manual to accompany my steadily growing collection of technical specs, including MySQL, HTML, and HTTP. I can remember it filling me with hope and excitement, helping us cross that bridge between our flash-driven web focus and always accessible data sources via these always connected devices, even though they had screens the size of stamps. Most of our responses at the time to the WAP technology was, what's the point of this? Well, today, you see, we currently have superbit, quadruple-powered, infinity gauntlet-charged broadband speeds on tap, and our sites can be heavy and laden with interaction, graphics and glitz. At that time, the mobile technology and screen size couldn't accommodate or manage much. But then came the iPhone, followed by Android. And suddenly, rabbit holes appeared. We developers dived in screaming, "Red pill, please!" And our complacency led us to grow homebellies. We have become a little lazy. What's the point in saving kilobytes of data when we need some stuff? Kilobytes? Pah! It's peanuts for our broadband connected society of today. Really, my point is this. Do we really care or understand our user base? I know we do. So how can we improve our code designs and technical debt to get out of a lazy programming interface frame of mind? I was personally looking for a way to increase performance and speed, at the same time reducing packet size and the cost of an API call, specifically for a mobile project, talking to a Node ACS service, interacting with one or more APIs. This diagram explains a very simple yet common flow of communication, where for a mobile application talking to a middleware layer, interacting with one or more APIs, and the potential paths our data may need to travel. CJSON and JSON with HPAC, now JSONH, returned from my Google Quest in searches for a JSON compression process. JSON for homogeneous collections seemed to be the most relevant for my needs. As David J. Barnes explains about homogeneous collections, they are a collection of objects with the same dynamic type. Arrays are the most common homogeneous collection objects. So why did I choose JSONH? Mainly from looking at this benchmarking test and comparison of the different technologies. We can see an 80 to 90% compression benefit. In reality, this may require a lot of work to your existing JSON return format. It still caught my attention. So how can we get set up to use JSONH? I've set up a simple 3-step plan to weave in JSONH into your Node ACS and Titanium mobile project. Step 1. Get the JSONH library. Get JSON minify. Include the libraries into your Node ACS project. Include the libraries into your Titanium mobile project. Optional step. Go make a freshly ground cup of coffee, tea, herbal drink of your choosing and enjoy. Step 2. Just goes over some of the specifics around including the project code into your library. They just need to be required in. Reference them so you can call on the libraries when needed. When actually dealing with data responses from the server, you want to minify the responses. In case it has spacing, comments, it optimizes the JSON you have. Now you want to replace the homogeneous collection with a JSONH packed version. This scenario expects that the data response from the server to have only one homogeneous collection of data suitable for compression and stored in the contents object. When returning the data from Node ACS to your mobile app, you want to return a stringified version of the object. If you send it as JSON, you will not benefit from the compression. In your Titanium mobile app, your success callback from the HTTP request made to the Node ACS instance should take the data response and unpack it. It should know what has been compressed in advance and only decompress that object. You need to first parse the response as it was sent as plain text. Then it needs to decompress the homogeneous collection object contents. Return the object back to your app and yes! What just happened was a theoretical walkthrough from another dimension, explaining a potential future, one where the possibilities of JSON compression tethered to your API responses and Node ACS instances were all intrinsically bound to your Titanium journey in the mobile zone. Seriously though, this flowchart gives some idea of what's going on with the data requests and callbacks, coupled with the JSONH usage. And that, folks, is that. I've placed a couple of links here to get some more info on this concept. It's still a little experimental, but I think it has some merit. It might make us think a little deeper on how we design and deploy our APIs. Also, it might allow us to save precious bandwidth and transmission data between our app and data source, resulting in snappier responses and happier customers. I'll see if I can bring all these components into a single project and follow up on tidev.io with some blog posts on the subject. Thanks for listening.